Everybody after a long break. Today I'm going to be making a video on the LeetCode question 2 sum. This is one of the most common LeetCode questions probably around, and it's also asked a lot of companies, and a lot of people do kind of find it hard, but it's honestly not a hard question, and we're going to break down how I approach this question and how you can solve this as well. I think it's asked at like Amazon, Google, and some other companies as well. So it's sometimes a common question, but it's not really a hard one. It's just really a question to see if you can, if you know basic understanding of some data structures. So I hope you're excited. But before we get on to the video, make sure to like, share, and subscribe to the channel. I appreciate all the support, and we're gonna be making a lot more videos now. So, anyways. Back to the video, let's get to it. All right, let's get started with this question called twosome from LeetCode. And here you guys can pause the video if you want and read the question, but I've already read it. And what we have here is we're given an array of integers, as you can see right here, and then we're also given a target value. And what we're trying to find is in that array, we're trying to find two elements that sum up to this target, and hence the name twosome. And you see it gives the explanation here. And what we're returning is the index of where these two elements are in the array. So in this case, we have 2, 7, 11, and 15. And so the two numbers that add up to 9 are 2 plus 7. And so 2 is in the 0 index place and 7 is in the 1 index place. So you see that our return is that. And the second example, in this array 3, 2, 4, we know 2 plus 4 is what equals 6. And so 2 is in the 1 index place, 4 is in the 2 index place. And so we're returning an array of 1, 2. Same thing with the third example, 3 plus 3 is what gives us 6, and 0 and 1. So 3 is in this, the first 3 is in the 0th position, and second 3 is in the first position, so we're getting that as our output. So how do we actually go about this? And I think there's two ways to really think about this question. One is the most naive approach, or the brute force approach, which is, I think we could just, in an array, we could start off with one element, so we start off with 2, and then we iterate through all the other elements to find the number that gives us the target, or in this case, I'm going to call it the complement here, which is basically just our target minus the current number that we're looking at, minus the current number we're looking at, current value, I'm just going to say that, and I'm just going to call that the complement. And we can do that, and if we don't find it in the current value, we just go to the next value. So I mean, if our target was instead like, I don't know, 11 here, and we were looking for a 9, we wouldn't find it, so we'd go to 7, we'd look for a 4, we wouldn't find it, go to 11, I mean, that is the value, so I guess we don't need another one there. And so something like that, but we go through every element, and so that kind of looks like a nested for loop structure, because we're going through every element in each iteration, because we're looking at a value, and we're looking at all the other values, and then if we don't find it, we go to the next value, looking at all the values after it. And so that kind of gives us an n squared time complexity. And this isn't really good, especially in most interview questions and most time algorithm questions. They're not really looking for an n squared solution, and so we can definitely improve on this. And here, I don't think memory is of a concern, especially in this question. I mean, it would have probably told us, but it doesn't really matter, I think. So I think we can go ahead and use some memory. And so how I would think about this is, if we can go ahead and use some memory, then what data structures can we use? And what I'm thinking of right now is a map, and here's why. So you see that we need two numbers that sum up to 9, right? So we have one value, and then we have its complement. So these are kind of like, what we can do is, at the end of the day, we want to return indices. What we can do is, we can take the current value that I wrote up here, and we can have that as our key, and then we can have the index of that position, and we can structure our hash map kind of like this. So the current value and the index. And what we'll do is, we'll go through every element, so it's just one swipe through the entire array. So what we do is we go 2, 7, 11, 15, and so we'd put this into our hash map. So it would be 2, 0, and that'd be just our hash map. And then what we do is we go to as soon as we put that in, we would first check, before we did that, we'd check in our hash map, do we have do we have the complement? So we can calculate the complement. So we check for 7, right? But do we have that complement in the hash map so far? And we don't, right? And then what we'll do is we'll go to 7, we'll put that in. So what we're looking at is 2 comma 0, 7 comma 1. And now what we do is we use the 7 value and we see, do I contain a key which is equal to my complement? And I do, right? Where a complement for 7 to get 9 is 2. And we do contain a key. So what we can just do is we can just return these two indices, and that we have our answer. And this would work for this example and the other 2 examples, and it should work for all examples, because we're really just using the power of a hash map to get like the element quickly, because in a hash map, to get these elements, to get as I said, contains key method, right? This isn't like a for loop search where it would take another O of n time. This is an O of 1 time just because of a hashing that goes on in behind the scenes in a hash map. And so that's why this algorithm and this approach is only O of n, which is much faster, even though this is our time complexity. Even though our space complexity is O of n, it doesn't really matter here because that's not really the concern. So I think this hash map approach should work. And so let's go ahead and code this up and let's see what we get. All right, so let's get started with the coding and let's go ahead and do the hash map approach. So I already have the classes I'm going to use here imported, and it's because LeetCode's dumb and it doesn't import them for you. So it is fine, it is what it is. We'll just deal with it. So here I'm initializing my hash map, and yes, I don't have very interesting and probably should be better variable names, but it is. I'm just gonna go with map. And here the problem wants us to return an integer array, so I just like creating it before, and it just makes it easy also. So I'm just saying indices, and then this is just gonna be a size 2 because we want the first and the second element, which is the complement. Then what we're going to do is we're going to iterate through the entire nums array. Oops, I said map, but you don't want to iterate through map. We just want to iterate through the nums array. And then what we're going to do is we're going to first compute the complement. And so how we do that is we do our target, like I said, and minus the current value, which is basically the value that we're at in the nums array. So this index I. And so that should be our complement. And what we're going to do is if map.size isn't 0, because if it's 0, then there's nothing there to check, so we'll just add the element in. But if it isn't 0, what we'll do is if it contains the key, which is our complement, and if it does, that means we have our 2 indices. So what I'll do is I'll say indices at 0 is going to be equal to map dot, or we can just make it I because yeah, we can just make it I. It really doesn't matter because it says you can return in any order here, so it really doesn't matter. So I'll just make it I, and I'll say indices at 1 is equal to map dot get, and the value, and that will just be our complements value, which will be our index values as we said. Otherwise, we have to insert into the map. So what we'll do is map.put. And what we'll put is the current value, and we'll put down the index at where we're at. So we'll do that, and I think that should be it, unless I made some mistakes, which possibly did. But let me just make sure. Yep, we have the key. We're gonna look at. I think this should work. So I have some syntactical error, which I hopefully do not. Yep, that seems to work, and yeah, it doesn't really matter. They said the order doesn't matter, so submit, and we'll see how it goes. Yep, that works. And to make this actually a little bit faster, what we can do is once we find these indices, we can just break, because there's only one solution, as they stated in the problem. There's exactly one solution, so there's no need of continuing on if we have found the indices. It's just extra computation for no reason. And so this will just be faster. I just want to make sure it doesn't break anything. Break. Anyways, yeah, and you saw I made it faster. And so, yeah, that was it. That was two sum. Not really a hard question. It's actually pretty commonly asked for some reason. I honestly think it's not too bad. But yeah. All right, so that was the question two sum on LeetCode, and I hope you understood it. If you have any questions, leave them down in the comment section below. Again, make sure to like the video, subscribe to the channel, and I hope to see you soon.